Hi, welcome back to Moose and Chemistry. This is periodic table naming cation B ionic compounds, lesson 1. So what's the difference between a cation B element and a cation A element? Well, we learned in our last lesson when we were talking about periodic table naming cation A ionic compounds that cation A elements only have one particular charge, right? Cation B elements have more than one charge. So let's take and do a couple problems to see how this works, okay? So I'm going to look at our first compound here, which we're going to call iron chloride, right? Normally we call it iron chloride, but now we're going to do this. We're going to put a little asterisk right here. That little asterisk tells me that we use the stock system. Stock system in naming chemical compounds. And that stock system uses something called Roman numerals. This is Roman numerals. All right, so now just remember every time you see an asterisk, we're talking about the stock system and Roman numerals. So let's go ahead and clear that out a bit. Get some space here. Great. Now, chlorine is in group 17. There it is. And it has a -1 charge. Well, that means we're going to put a -1 right here. So 2 times -1 is -2. The anion determines the cation. The cation determines the stock number. So we're going to put a Roman numeral 2 right there. And that's going to be iron chloride. Pretty simple and straightforward. But what if we had this situation? FeCl3. Oh, chlorine is still in the group 17. It has a -1 charge. So we put a -1 there. And don't forget we have the asterisk here. So 3 times -1 is -3. So the anion determines the cation. The cation determines the stock number. In this case, we're going to have Roman numeral 3, right? And this is going to be iron 3 chloride. Oh, look at this. The element iron can have a +2, a +3, or even a +4 charge. So it's a cation B element. Okay, hey, it's starting to make a lot of sense. So let's go ahead and let's try another compound, just to show you that everything is pretty cool here, okay? All right, in this case, we're going to try mercury, okay? So mercury, we're going to say, let's try mercury, and let's get H for mercury. And we're going to call this mercury HGS, right? Mercury sulfide, right? So in this case, we're going to put a little asterisk here. And we're going to, you know that sulfur is in group 16, right? So it has a -. So now, here we go. The anion determines the cation. The cation determines the stock number. So we're going to write a 2 there. In this case, we're going to have mercury 2 sulfide. Hey, pretty cool, right? Now wait a minute. What if I had this situation? What if I had HgBr? Seems like a kind of odd one. So bromine is also in group 17 and has a -1 charge. So the anion determines the cation. The cation determines the stock number. So now we have mercury 1 bromide. They're both mercury. But yet, when we use different anion elements, we get different names. Okay, now I want you to think about this for a second. Mercury right here can either have a +1 or +2 charge. In this case, when it's used with halogens, it has a +1 charge. So it has an oxidation number of 1. Over here, when it's used in group 16, it has a -2 charge for sulfur, so it has a +2 charge for mercury, giving us a and Roman numeral. All right, let's look at one more. Think about this one. I know. Let's try lead. Lead would be good. So we're going to use lead. In this case, we're going to use the same anion, right? So we're going to call this PbCl2. So again, we have our little asterisk up there to let me know that I'm using the stock system, right? So chlorine itself is a -1 charge because it's in groups 17. So we're going to put a -1 up there. Pretty cool, huh? Now, although we know that lead is in group 14, it's supposed to have a +4 or a -4 charge, that may not work out the way we think it's going to work out, right? So let's take a closer look. 2 times -1 is -2. So the anion determines the cation. The cation determines the stock number. So you're going to have lead 2 chloride. Wow, okay. Let's look at PbCl4. We're going to put a little asterisk up here to remind us that we're using the stock system. Okay, hey, chlorine again has a -1 charge because it's in group 17. So there's chlorine, right? All right, so it has a -1 charge. Same elements, guys. Same elements. So 4 times -1 is -4. So the anion determines the cation, which we're going to do 4 right here. The cation determines the stock number. So we're going to call this IV. And we're going to make this lead 4 chloride. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moosine Chemistry.